I'm Brian Peltonen, co-founder and CEO of parcosm.ai. So it's finally spring again in Boston. The city has come out of its hibernation. The flowers are in bloom. The Red Sox are playing at Fenway. Keytar Bear is out playing his keytar. And it also marks the start of one of my favorite activities, which is observing ants. And as we all have been hearing a lot about AI agents recently, I think as unlikely as it is that those little creatures have a lot to teach us about the transformation that's about to hit all knowledge workers. So if you stop anywhere and sit outside for a while, after a very short period of time, you'll start to notice ants moving about. These little creatures outnumber us by something like a factor of 2.5 million to 1. They cover the entire habitable world, and they're remarkably effective at a large variety of tasks. They can find the shortest route to food. They can build highly advanced thermo-regulated architectural structures. They employ remarkable offensive and defensive tactics. And they do all of this in a very fault-tolerant way. Their system's redundant and it's adaptive. They don't rely upon the perfect execution of any single individual. Instead, they rely upon a massive amount of resources thrown at different tasks. So this is a photo of a prized possession of mine. It's a copy of the Pulitzer Prize-winning magnum opus by Hall, Dobler, and Wilson, The Ants. And in addition to being signed by E.O. Wilson, if you look closely on this, you'll see the luggage tags from Caesar's Palace. About 20 years ago, I was spending a lot of time there. But I don't really like to gamble, and I'm also not very good at it. Instead, I was there because I was developing algorithms. I was working for a company called Ecosystem that was founded by Eric Bonobo, one of the world's leading experts on emergent behavior. So my colleagues and I were out at Harrah's, now Caesar's, because they hired us to use AI to transform the way that their business operated. And with AI agents now in such a broad discussion, I've been thinking a lot about agents, particularly what has changed, what stayed the same, what might be coming next, and how all of us can best utilize what's coming ahead. So agents have a really long history. Arguably, it goes back to John von Neumann's work on self-replicating automata in the 1960s. Von Neumann was one of the most brilliant people who has ever lived. He laid out the mathematical frameworks for quantum physics. He was a key member of the Manhattan Project. He founded the field of game theory. He warned of human-caused global warming back in the 1950s. And he also designed the architecture that all modern computer systems, or pretty much all modern computer systems, use to this day. And he did that in 1945. What defines an agent? Agents have generally been defined as computer programs or parts of computer programs that have some form of autonomy. They have no central overseer that dictates their individual behavior. They have the ability to interact, particularly with their environment and other agents. They have some ability to perceive and an ability to react to those perceptions. They have goals that they pursue through their own initiative. Agent-based models, or ABMs, have been used to model all kinds of things: foreign diplomacy, trade, ant colonies, traffic simulation, slime molds, how information flows through social media networks, as well as many other systems. They also almost always have a way to bring computer resources just to their knees. You can always add more agents, you can make them more advanced, give them something larger to work on. And also, instead of running just one simulation, you can run thousands or hundreds of thousands of these simulations. And it's kind of like weather simulations. You know, when you see a path of a hurricane, the way that scientists generate that is by creating thousands and thousands of different individual simulations and then seeing where most of those landed. And that gives you where the hurricane is most probably going to land. Similarly, with agent-based models, you can do this. You can run things thousands of times, hundreds of thousands of times, even more. And sometimes you can find very rare outcomes, but that have very important implications. But before we talk about why everyone is suddenly talking about agents, I think it makes sense to talk about some of the changes that have happened with AI recently. So the initial framework of neural nets upon which large language models are based was developed in 1943, but training those to converge on a desired output, that didn't happen until the 1960s. Really, it was refined in the 70s and 80s, but by the 90s, These systems were widely used for converting handwriting into computer text, and they were also used by all the major banks to look for credit card fraud. But the systems faced a lot of different challenges. They needed manually labeled data sets, and they also pushed the available computer resources in that era. They also struggled with context. In the 2000s and especially the 2010s, researchers achieved major breakthroughs. Huge amounts of training data became available via the internet. All those images of pets on Instagram and Pinterest were ready-made data sets for researchers to just rip through training different models. Researchers also found ways to extend the memory of neural nets, and computational resources exploded. The computer that I have today is 1,000,000 times more powerful than the computer that my brother had when he went to college in the mid-90s. And I was very envious of his computer in the mid-90s, by the way. So all that is to say nothing, too, about the immense resources available via the cloud. But the biggest breakthrough happened in 2017. That's when Google unveiled the transformer architecture. This is when neural nets became aware of the entire context of what was passed into them, instead of just processing isolated bits one after the other. This is what ignited the arms race of all the large language models. And these large language models are incredibly capable. But as I think everybody has experienced, they also have some major flaws. So now, combining these, we have agents that can be powered by these large language models. They have real agency in the world. Before, they were locked into their little sandboxes. They could do things and perceive data only within those confines. But now they've jumped out of that sandbox and they can do actual things in the real world. We have agents that can order products. They can communicate with customers by plane tickets. They can buy or sell securities. They can scan for cyber vulnerabilities. Anything that's available through the internet is now available for agents to interact with. And by utilizing these LLMs, these agents have become very, very smart in certain ways, but in others, they still show glaring flaws. But remember about a year ago when image generation was still getting the number of fingers or limbs wrong, and now that problem has pretty much seemed to go away? Similarly, the brains behind these agents are going to continue to improve. I'm guessing most of the people in this room have had the opportunity to manage teams of individuals. Some of those individuals on your team have capabilities that far exceed your own. Others are weaker in some areas. But as managers, you find ways to work with that balance of strengths and weaknesses, and you employ checks and balances and oversight where needed. Overall, the team can accomplish things that any of the individual team members can't do on their own. So we already have agents that can read, they can write, they can code, they can summarize documents, they can perform small tasks. They work already at a breakneck speed, and they don't need to rest. But imagine a world in which computational power goes up by another 1,000,000-fold. In that context, you may not just assign a task, like writing a document or a report, and just assign it to one agent. In that case, you may give it to many agents and see who produces the best results. You might give it to thousands of agents and then have other agents that rate those, analyze it, and figure out which ones are best in a big competition to see what can generate the most optimal thing for your particular needs. So what will it mean if we move towards a future where every individual contributor in a large organization has their own ensemble of these agents that are working for them? So imagine this future where there are these vast armies of AI agents that work tirelessly behind the scenes. We already have language models that can pass the bar exam, they can pass medical boards, but those same models struggle to do things sometimes like count the number of R's in the word strawberry. But like any team, systems can be built with checks to ensure that they meet requirements. Hobbyists and practitioners aren't waiting around for AI to surpass human abilities in every domain. Instead, many of us are already using agents today in lots of different ways. These agents aren't perfect, but just like an ant colony doesn't require perfect individual ants, the ant colony thrives because of the sheer numbers and relentless activity. We're entering an era where humans will manage not just a few agents, but thousands. Some will make mistakes, just as some ants take wrong turns, but we don't need perfect AI. Just like we don't need perfect ants, we don't need perfect employees. What we need is a system that embraces abundance, because when you have thousands of agents working together, a well-designed AI system won't fail just because some agents falter. The beauty of this system is that it'll be designed to be resilient, not flawless, and the output will be greater than the sum of its parts. Many of these building blocks are already here today, and it rests upon all of us to figure out how to adapt and to thrive in the kind of world that's coming. Thank you.
Great. All right.